Now the next problem is longest common subsequence. It's a part of dynamic programming. Some gate questions are there. In gate questions, they have just asked the formula, nothing else. The problem is lengthy. If a problem is given to you, then for solving that one will take some time, but a short question can be given on this. And recently they have asked a short question also on this one. So let us understand what the problem is. Longest common subsequence. Suppose there is one string, 1. Then string 2, there are two strings. There is nothing like main string or substrings. These are two different strings. Then you have to find out the common sequence of alphabets. So what is the longest common sequence? So if you see the alphabets in string 1 and string 2, they are common. They are common alphabets. So their relative positioning must be same. Relative positions must be same. So let us see. This is A, and here also this is A. Then next, this is B, B. Then okay, this is A and this is A. They need not be continuous. There can be some other characters also in between, but the relative position first comes A, then B, then A. Here also first comes A, then B, then A. Then next D is there, D. So yes, there is a common sequence of, that is longest common sequence of A, B, A, D. Right? So let us take any other common sequences there or not. Any other common sequences there or not, let us check. So I'll start from here first. B, yeah, B is there. Then A is there. Then C, yes, C is there. That's all. So A, B, A, C is also one sequence. B, A, C, B, A, C. Then B, A, D is there. So B, A, D. So B, A, D is also one sequence. So these are some of the sequences I have found out, right? Next, one more. Just I will take A, B, and A. A, B, and A. So A, B, and A is a part of this. Then one more. A, A, C, C. A, C is also there. So there are many sequences, but among them the longest common sequence is this one. So this is of length 4. So we want this one. So the problem is to find out longest common subsequence of alphabets. So let us learn how to find out this one. See, I have checked the alphabets and I have shown you. But if the string is very lengthy, is it possible that by checking them you can find out correct answer? Maybe you can find out, or maybe you are doing some mistake, but we want some procedure so that we can write a program and the program can find out, and the program cannot be wrong. It cannot miss anything. We may miss it, we may not see some characters or oversee some characters, just ignore some characters by mistake, not intentionally. But program will follow the correct procedure and gives you the perfect answer. So we need a procedure so that we can convert it into a program. So what is the procedure for that? So I'll show you the procedure how it can be done manually first of all. So we will take these two strings. So I'll take a strings B, A, C, B, A, D. Then A, B, A, Z, D, C, and create a table. Okay, this is string 1 and this is string 2. Whichever side you want, you can take it, no problem. Here you can take string 1, there you can take string 2, any way you like. Now this is 0th index, so first mark first row as all 0 and the first column is also 0. You can see that the first row is not labeled with anything and the first column is not labeled with anything. First row and first columns are not labeled with anything. Then the procedure. Let us see the procedure. Follow the row. Compare the first letter of second string with the letters of second string. Compare them. See, 1, A with B, they are not matching. They are not matching means you either take this one or this one, whichever is maximum. So both are 0 only. Then, now A and A, they are matching. So when they are matching, take the diagonal one and add 1 to it. So 1 is added. Then A and C, they are not matching. A and C, they are not matching. So take either this one or this one, but maximum 1. So maximum 1 is 1. Take 1. Then this one, they are not matching. So take any one of these two, that is maximum. Then this one and this one, they are matching. So take the diagonal one and add 1 to it. So 1 is added. Then these are not matching. So take the maximum of these two, that is 1. This is how we fill the table. Then next, B, this is matching. Matching means this plus 1, 1. Then this is not matching. So maximum 1. This is not matching. Maximum 1. This is matching. So diagonal plus 1. Then not matching. So this is 2. Then this is not matching. So this is 2. The next one, not matching 1. Matching 1 plus 1, 2. Not matching 2. Not matching 2. Matching diagonal plus 1, 3. Not matching 3. Z. Z is not there. So this is 0. Take 1. This is 2. This is 1. So take 2. Take 2. Take 2. So the numbers will come as it is now. Then D. D is matching here. So till there these row values only will come. If you compare also and do it, you will get the same row values. So 2, 2, 3. Now this is matching. So 3 plus 1, 4. Last one, it's matching here. So till there these numbers will be same. Now this is matching. So 2 plus 1, 3. Then 2. Then 3. Then 4 is greater. So when not matching any of the greater number, that is in previous row or previous column, we take it. Okay. Now we got the table filled. Now which is the longest common sequence in this one? Right. We will find out this one. So start from here. This 4 we got it because of this. And this 4 we got it by adding 1 to this. So diagonal is going here. So D is taken. Then 3 we did not get, okay, we got a 3 because of this. Okay. Then this 3 we got it not from here because this is not maximum of these two. This we got it by adding this. So A is also there. So A is also there. Then this 2 we did not get as maximum, but we got it by adding 1 to this one. So this one. So C is also there. Right? So A, B, C, A. Then this one we did not get, we got it because of this maximum. This one we got it by adding this one. So this is A. Oh, sorry, this was B. I wrote C. Sorry. Then in diagonal, this is diagonal. So this we are getting it as A. A, B, A, D. So A, B, A, D. That is the answer. So wherever it is taking diagonal, D. And here we got diagonal. So this is A. And here we got diagonal. So this is B. And this is A. So A, B, A, D is the answer. And the answer is 4. So this is the method for finding longest common subsequence. So if I say this string as S1 and this string as S2, then the formula is what the formula we are following. If S of 1 of I is equal to S2 of letter J, then that is row and column. This has S1 row and this has column J, Si and Sj, they are equal. Then let us call this whole table as L. So in L of I comma j, if they are equal, right, then here we have to take L of I minus 1 comma j minus 1 plus 1. Otherwise, L of I comma j will be maximum of L of, that is table of I minus 1 comma j or L of I comma j minus 1. This is the formula for longest common sequence. So formula is important. Most of the gate questions are there. Means 2-3 questions are there based on the formula. Only formula he has asked, right? Because solving this and getting the answer is too lengthy. But if the string is very short, you can easily check it and answer it. So some questions are there on this one. That is, find out what is longest common sequence. So take this one. So what you have to copy is, you have to find the longest common sequence. This is longest common. These are the other subsequences. And how the table is filled, I have shown you. So you have to do this, copy this one. And then this is the formula by which we have filled this one. How we check this? If this is matching, then this is diagonal one, then plus one. This is diagonal one, then plus one. If this is not matching, then take either this or this, whichever is maximum. So this or this, whichever is maximum. So this part is over. This is the formula followed for filling the table. Over. So I will remove this